Hello everyone. In this video we're going to discuss about what binary search algorithm is. In our previous video we've discussed about linear search. If you haven't watched that video, please do watch that video and also do watch the videos which I made on arrays. So let's get started.
Let's talk about binary search. So the first thing which you need to remember is if you want to do binary search, then the array has to be sorted. And the second thing is it follows divide and conquer approach. Okay, so now let's take an array. Here I'll be drawing a very big array. I'll take a big array this time so that you can understand this concept very clearly. In binary search approach, we take three variables. The first one is the left variable, which is pointing to the 0th index, and then the r variable, which is pointing to the n-1 index, and we're gonna take the mid value, which will be l plus r by 2. We're gonna take the floor value of l plus r by 2. Okay, now let's say that I want to find whether there is an element 21 present in this particular array or not. Now let's check out how we are supposed to find it. As I said, L will be pointing to the 0th index, R will be pointing to the last index, and the mid will be nothing but L plus R by 2. So here in this case it would be 4. Let me put a table so that it would be very much clear what is the value of L, R, and how everything is going on. Initially the value of L is 0 and the value of R is 9, so the value of mid is 4. Now we have three cases over here: case 1, case 2 and case 3. Case 1 is if the given element is equal to the element at the mid position. So if the given element here is 15, then the given element is equal to mid position. Second case is if the given element is greater than the element at mid position, and the third case is if the given element is less than the element at mid position. Okay, so we have three cases over here. Now I will also write what you are supposed to do when you get these three cases. Let me erase this part. If you're noting this down, please do note it while I'm telling, because I have space constraints, so I'm erasing things. So if case 1 gets, like, if the given element is equal to the mid element, then you are supposed to return or print the mid element. If the given element is greater than the mid element, then you're supposed to make the left position equal to mid plus 1. If the given element is less than the middle element, then you are supposed to make the right position less than the middle element. Okay, so let's look at our case. In our case, we are supposed to find the element 21. Now 21 is greater than the mid element, so it is present here, right? So if it is greater than the mid element, we are supposed to move to case 2, where if the given element is greater than the mid element, the left position would be equal to mid plus 1. So what we will do is we are going to erase this position from here, and mid plus 1 means L will be here. I'll write the new positions now. L is 5, R is 9, and the mid position will be 9 plus 5 by 2, which would be the floor value would be 7. So let me erase this mid. Okay, now again the comparison. Is the given value greater than the mid element or less than the mid element? It is less than the mid element. Then we will straightly jump to case 3, where if the given element is less than the mid element, then we need to make this right position mid minus 1. So here we are going to remove R and we will point R over here. Now let's again write our values. L is pointing to 5, R is pointing to 6. So 6 plus 5 is 11, 11 divided by 2, the value would be 5. The floor value would be 5. So we are supposed to remove this mid here, and mid is also pointing here. Mid is pointing at 5. Okay. So now again the comparison starts. Is the given element is greater than mid or less than mid? It is greater than mid. Then we are supposed to go to case 2. If the given element is greater than mid, then the L would be equal to mid plus 1. L is pointing here, so that would be equal to mid plus 1. So we need to remove this L value here, and L will be pointing at 6. So again note down the values. I hope you are understanding everything. So L is 6, R is 6, 6 plus 6 is 12, 12 divided by 2 is 6. So the mid value will also be equal to 6. Okay. So mid is also pointing to 6. Now is the given element greater than mid or less than mid or equal to mid? Now in this case, the given element is equal to mid. So in this case 1, we are supposed to return the mid value. Okay. So here the loop ends. The whole loop ends. This particular thing works recursively. What do you mean by the word recursive? Recursive means the function repeating itself. So here, until and unless you are getting the value, the function was repeating itself. It was searching, is it greater than this or less than this, then it is going to the case, and then the values are getting changed, and it searched until and unless it got the answer. So here the function is repeating itself. So this is a divide and conquer approach which works recursively. Okay. And binary search only works for sorted arrays. You cannot do this for not sorted arrays. Okay. This is one thing. Now, what if I want to search, let's say, for an element 26. I want to search for an element 26, whether this particular thing is present in an array or not. Now, how that thing works and how am I supposed to show? For example, if the given element is present in that particular thing, then you know how to print it. But if that element is not present in the array, how can you show in code that that element is not present? That thing we will see. First of all, we will see how this algorithm works when you give element which is not present in the array. So here, as usual, L will be pointing here, R will be pointing here, and L is pointing at 0, R is pointing at 9, so the mid value would be 4. Now 26, is it greater than the mid value or less than the mid value? It is greater than the mid value. So if it is greater than the mid value, then you are supposed to shift your L to mid plus 1. So it would be, L would be pointing here, R is here, and so here L would be 5, R would be 9, so the mid value would be 7. I'm erasing the mid here and pointing it towards 7. So this is the mid value. Now again we need to search, is the given element greater than the mid value or less than the mid value? 26 should be greater than the mid value. So this is why I said that the array has to be sorted. Now you're easily telling whether it should be greater than or less than. So 26 is greater than 24, so it has to be on the right hand side of the mid value. So again, what you're supposed to do, L equals mid plus 1. If it is greater than, then you're supposed to do L equals mid plus 1. So here the L value is at 5. Now L value becomes 6. This is the L value, and R value is at 9. So the mid value will be 7. The mid value is 7 itself. Now again you are supposed to search. Is it greater than or less than? It is greater than. So again L will become mid plus 1. So Now L will be pointing where? L will be pointing here at 7. So again update the table. L is at 7, R is at 9. So 9 plus 7 would be 8. So now the mid element would be pointing at 8. Again we need to search. Is 26. Here the mid value is 27. It should be greater than or lesser than? It should be lesser than actually. So wait, first thing I'll do is I'll erase this part like this so that you can understand where L is pointing. L is pointing here, okay? So L is pointing at 7, R is pointing at 9, and this is pointing at 8. So here it should be lesser than. If it is lesser than, then we make R equals mid minus 1. So R position will be 8. R will be pointing at 8. So L is at 7, R is at 8. So 15 divided by 2 would be 7. So L will be pointing at, like, mid will be pointing at 7. Okay, mid will be pointing at 7. L and R would be pointing here. Now 24 should be greater than. Okay, now 20. Wait. Now 26 should be greater than 24. So it should be pointing more. So it should go to L equals mid plus 1. So the L value is already greater than mid plus 1. See, L crossed mid. If you could see here, mid is pointing at 7. L is pointing at 8, and R is also pointing at 8. So from this, what you can say is, if L is greater than R, or if the given mid value is, or if you could say that if mid value is less than L, in these cases you can say that element is not found. So right now we are on our IDE. Actually this time I've typed the whole code before itself because my system is actually kind of lagging right now. While I'm typing, it's lagging and it is not it's not very smooth. So I typed everything. So for this time, please. So here we have created a method int binary search, inside which we have three parameters. One is the array, and the second one is the element, and the third one is the size of the array. So here int the left position, int L equals 0, and R is the right hand position, which points at the final index of the array. Now while L is less than or equal to R, so while I was explaining this particular algorithm, I said that if L is greater than R, like if the left position is greater than the right position, then there is no element present. So if the element should be present, then the left position should be less than or equal to the right position. Then only there is a possibility for the element to be present. So while L is less than or equal to R, int mid equal to L plus R minus L divided by 2. R minus L in the sense, see, R, for example, L is 0 and R is 9. So 9 minus 0 would also be equal to 9. So that is why I've taken like this. Like if I've taken L plus R divided by 2. Somehow it is not showing up, so I took it this way. Then it was working. Okay, so int mid equals L plus R minus L divided by 2. After that, you know the three cases, right? So this is the case 1. Wait, I will write here. This is the case 1. If the mid element of the array is equal to the given element, then it needs to return that particular thing. Then the case 2 is, if the mid element is lesser than the given element, then L equals mid plus 1. The left position should be made equal to mid plus 1 index. If these both cases don't work, then I wrote the else case, and R equals mid minus 1. If you want, you can also put a if statement over here, that is up to you. So I kept an else statement over here. Then R equals mid minus 1. If this particular while loop doesn't run, then like if the element is not present, then we return minus 1. And coming back to the main program here, since this particular method is not static, we need an object to access that particular method. So I've created an object, binary search ob equals new binary search, and then I've taken using the scanner class, I've taken in the input of the size of the array, the elements of the array, and the element that has to be searched, and whatever value I get after that, in order to again act like, I've taken these values, and these values I've kept in this particular method, and the result which I get, I stored that particular thing in a variable called as result, int result. I stored it here, and after that, if result double equals -1, means if there is no element, if you don't have any element that is present, then only it shows -1, right? So if the result is equal to -1, then we print element result is not equal to -1. It goes to the else statement, which is element found at index, and the index would be printed over here. So let's run this particular program. As you could see here, it is asking enter the size of the array, so it's 10. Then elements of array 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now I want to search for the element 1. So it is showing here element found at index 6. So this particular program is working. So I hope you understood this program.
I hope the concept and the code which were explained in this video were very clear. Thank you so much for watching this video. Please do like, share and subscribe to my channel. We'll meet in the next one.